So we're going to wrap up now this section on brains and cognitive neuroscience with a little bit of warning and a we need to discuss the way in which the emerging pictures of the brain are integrated into our contemporary technologically rich environment. You'll see the word neuro, the prefix neuro, used an awful lot. Here's an example, very easy to find from the web, someone called NeuroSky Body and Mind Quantified. It's my hope that anyone using the prefix neuro will be looked upon skeptically. This reeks of bullshit, but there's no shortage of bullshit. Remember at the outset of this, we said the brain is mysterious, still. The brain is in some respects sacred because it's so central to who and what we are, even though we don't understand it very well. We said that there are differing ways of interpreting the brain. Some people like to look inside and project their own self-image onto it as if it were a mirror. Others regard it as an integral part of the body, as an organ, much like the kidneys or the thyroid, and that these concerns means that the brain is always political, the way in which we consider the brain. Now, you'll meet an awful lot of stuff like this. The mind's limitless power. There's the galaxy brain. We've learned now those blue brains are always a sign of trouble. And you'll find absolute nonsense wrapped up around that galaxy blue brain wherever you meet it. Here it says you have 70,000 thoughts per day. Nobody knows what a thought is. There's no definition of a thought. Nobody ever counted thoughts. Thoughts become things. Pure bullshit. And there's lots of it. From NeuroQ. Here's a device that you can buy today on Amazon for a mere £236. It trades on the idea of the EEG, which people have a very hazy understanding of, and gives you a headband that you wear with sensors. And in this instance, it's used to control your meditation and make sure you're doing it right. This is desperate preying on the ignorant. You'll find devices like this that trade on the vague understanding people have of EEG. You'll find all kinds of variants on it. One thing they're used for, or used to be used for a few years ago, I don't know if it still goes on, is game controlling. So the idea was that you could get a little headband, which would have 2 or 3 sensors on it, put it on your forehead, and with this you could control a video game, console game, with the power of your mind. Now, remember how terrible the signal, the EEG, is diffuse variation on the scalp that's indicative of nothing very clear. A few years ago, we bought one of these just to have a look at it, and we put it on, and it came with a little demo, and there was a cube spinning, and you put on the headband, and you're told to practice changing the direction in which the cube spins just by the power of your mind. So you put on the headband, and you sit there, and you go, it's not going. Oh, did I just make it do that? I'm going to make it do that again. I can make it do that. And you can reverse the power of the direction of spin of the cube. Unfortunately, it took about 2 minutes of analysis to figure out that what's going on is not EEG at all. It's picking up the movement of the forehead. If you sit there and you concentrate, you're likely to move your forehead, a signal hundreds of times bigger than any EEG signal. And so simply by doing this, you are influencing what happens on screen. Now the neuro prefix proliferates. There are so many neuro this and neuro that. They're not all nonsense. Neuroscience gives us tons of things to talk about and to think about. So the business of neuroethics, for example, could be nonsense, but it could also be a very serious discussion about what the ethical implications are of understanding the brain in one way rather than another. Neuroaesthetics could be rubbish. It could be trying to tell you what to taste or what products to buy, but it could also be serious consideration of the manner in which sensation and perception work. Neuroeconomics and neuromarketing are different. These are undoubtedly rubbish and dangerous rubbish. The language with which we speak of money, economics, and politics is not the language with which we speak of the brain. They don't mix. And to lay claim to findings about the brain, which are always misunderstood, and to apply them in the field of economics, or worse still, marketing, is shameless in today's society. There used to be a very good blog called Neurobollocks. You can go back and check out old posts. It hasn't been updated for a few years, but it has lots of wonderful examples of this kind of neuro creep. And there's also a Twitter account which is currently active. Let's just take an example of neuromarketing. Now, marketing sort of generates its own activity. If you can get people to buy stuff, you're going to do whatever it takes. If we can draw on anything at all, neuroscience, astrology, magic, whatever, as long as we can sell products, marketing is going to go on. So the findings of neuroscience intrigue us, and so it's not surprising that people try this out, try to find out how the findings of neuroscience could help them sell more stuff. One study, and I'm not even going to dignify it with a reference, can stand for this field. This was an fMRI study. fMRI, you remember, always involves a contrast between at least two experimental conditions in which we measure regional blood flow and look at the difference between the two conditions in terms of regional blood flow, and we can locate that regional blood flow within the brain very well. In this particular one, there was the two conditions are one in which people taste either Coke or Pepsi without knowing what it is, and one in which they taste either Coke or Pepsi, but they know what it is. When they don't know what it is, about 50% of people say they prefer Pepsi and 50% of people say they prefer Coke. The report of this already in describing the experiment said that when the taste happened, reward centers in the brain lit up. There's no reward center in the brain. You'll often find the brain chemical dopamine drawn into fantasies about reward centers, especially when it touches on addiction. People like to completely misunderstand brain science and bring it into their favorite religious crusades. But in the contrast involved here, on the one hand, we have them choosing tasting drinks and expressing a preference when they don't know what it is. But when you tell them what it is, about 75% of them prefer Coke, showing that Coke are very good at marketing and branding. It's probably Pepsi paying for this study, to be honest with you. In the study, it said when they knew what it was, a new area in prefrontal cortex lit up. Now, of course, no area lights up. You may detect an increase in regional blood flow that could be located in the prefrontal cortex, which is only the biggest mystery in the universe. But the simplistic association is that we have found the part of the brain responsible for brand awareness. I'd like you to critically consider this. And I'd like you to realize that it is complete horse hockey and that the brain cannot be treated in this manner. So when you see the prefix neuro, already be cautious. And if money is involved, wear your tinfoil hat, wear your safety goggles, wear your knee pads. Now, one area where it's hard to keep fact from science fiction separate is in the area of brain-computer interfaces. So on the left there, the picture shows the usual techno-sci-fi fantasy of a magic brain which is spewing stuff out into the consciousness. And look, it's going into a Mac computer, which is everyone's ideal representative of technology. That has nothing to do with brain-computer interfaces. We have extraordinarily good brain-computer interfaces. They're called fingers. Computers were engineered to be interfaced with using fingers. That's what your brain-computer interface is, your hands, and it works perfectly well. That said, people have tried to record signals, usually EEG signals, directly from the head, and to use that to control something on a computer display. A rather different idea. And there are good reasons why you would do this. So the principal subjects for whom this research is addressed are those with terrible, terrible medical conditions, neurodegenerative conditions in which the ability to move the body goes away. So we get this in syndromes like ALS or locked-in syndrome. If you are severely immobilized, you may not even be able to move your eyes to signal, in which case any small signal you can give would be life-changing. We'll see that there have been advances in increasing mobility in neuroprosthetics, that is, attending to the peripheral nervous system, not the central nervous system, not the brain. We've seen the exploitation of EEG in entertainment, and of course there's a lot of military research here. There's always military research. Let's have a little bit of a look at what some of this is about. So, neuroprosthetics is the business of intervening in the peripheral nervous system to bridge a gap. For example, if someone has severed the spinal cord or severed a nerve, or to provide an interface between the peripheral nervous system and an artificial hand or leg. Neuroprosthetics is a very sensible, very practical, very grounded engineering field that has made remarkable advances. But the brain-computer interface is somewhat different. Here, the idea is that you will use sensors in order to record a signal which will influence the cursor on a computer screen. So the brain signals are signaling some kind of intent, and usually we're interested in the brain or the head itself. Now, this is not going to be easy, but the goal here is not some kind of science fiction world. It's to provide some degree of communication and control to people who are totally paralyzed. So here's what a brain-computer interface looks like under these circumstances, one used to communicate. Imagine you're staring at this screen and you want to write a letter to your mom. A ball comes in from the left-hand side and it moves across the screen. As it moves, there's 4 possible targets. The top 3 targets are subsets of the alphabet, and the bottom one is a backspace. With a lot of practice, you can learn using EEG to steer this ball gently towards one or other of these targets. And when it hits, for example, the top one there, which is A to H, then the screen is replaced with another screen which gives you the subsets ABC, DEF, and GHI. So now the ball comes in again and you steer it towards one of those. Having found this subset of 3 letters, now the screen is replaced with just those 3 letters and the ball comes in again and steers, and you aim at one of these. Congratulations, you just typed 1 letter. So it's hardly efficient. It's not a good interface to a computer. You have extraordinarily limited control, but it can be a lifesaver. The way it works is you're reading an EEG signal from the scalp, which is, as we said, it's a signal that doesn't interpret itself. We don't know what it means, but you can learn voluntarily to influence the laterality of it a little bit, enough to make a 1-bit discrimination so that the ball can be told to go up or to go down. That's it. That's what brain-computer interfaces are. They're, if you're dealing with people who have this need, one thing you do is typically open up the head, take out a bit of the skull, and place those electrodes directly onto the cortex. Now, you're not going to do that for gaming purposes, but that gives you a much clearer signal, which will be is much more likely to be something you can get a small degree of voluntary control over. Now, you're not exercising the power of your mind. Some people can wiggle their ears. It's kind of an ability some people have. Likewise, you can learn to move this, but who knows what's going on underlyingly. We just know you can do this and we can make use of it. So brain-computer interfaces is a serious business. It's not for gaming purposes, and it's not the world of science fiction. It's the world of painstaking engineering to help people who are suffering. But the remarkable successes of late have largely come in addressing the question of neuroprosthetics. As we said, intervening in the peripheral nervous system, not the central nervous system, either to bridge a gap or to provide an interface to an artificial limb, an artificial hand or an artificial leg. Notice that these kind of engineering interventions, both the brain-computer interface and the neuroprosthetics, they don't rely on any theory of mind. They don't care whether you believe in the computational theory of mind or some other theory of mind. They don't traffic in that business. They're sensible engineering and clinical applications. So that's a word of warning. The term neuro gets mixed up in all kinds of things, and sometimes it's hard to sort out the sensible, the productive, the genuinely creative and useful from the complete rubbish. And there's loads of complete rubbish to go around. So be careful when you see the neuro prefix.